Okay, welcome back to the seminar after a short break. We will now have our second speaker, Franziska Kirstein, and she's coming from Singapore / Denmark. Her company, BlueOcean Robotics, resides in Denmark, but she's also working from Singapore. And I think she got involved into robotics due to her master's into human-robot interaction. And ever since she plunged into it from the more business side of point of view from BlueOcean Robotics, but she's also now helping in the EU Robotics Topics Group Sustainable Robotics, and she will now give a talk about the combination of the business side of robotics and also the sustainability aspect in this topic or subject. Welcome, Franziska. Give it up. The floor is yours.
Thank you. Okay, let me get my slides on. Yes, thanks. That was a quite proper introduction. I'm gonna actually talk today about some work that I've been doing since I started at BlueOcean Robotics in 2014 until maybe 2020, 21. That is the design and development and manufacturing that has happened afterwards, of course, of these two robots that you can see on the slides with sustainability in mind. And right now we're in the commercialization phase of those robots, but back then we started with nothing than just an idea of what problem we wanted to solve. I work at BlueOcean Robotics. We have right now 3 robots in our portfolio, and today I'm going to just focus on the 2 of them. You'll hear more about that just in a bit. Yeah, BlueOcean Robotics is located in Odense. We are actually in Odense quite a lot of robotic startups. It has been initiated by Odense Robotics. You might know Odense also and Odense Robotics from the European Robotics Forum last year. It's quite an ecosystem concerning robotics where you can exchange ideas, exchange expertise on how to start up your own robotics company, and I think it was mostly initiated through the 2 probably you know them, 2 companies, Universal Robots, Mobile Industrial Robots, that we have there that drive the ecosystem also. And of course, Odense is the hotspot. It's companies from all over Denmark that are joining, and you can see it's around 300 across the country, but I think we're slightly over 100 robotic startups in Odense. So really good location to come up with a company. Since BlueOcean Robotics was founded in 2013, we have been interested in making robots for humans. So that fits very nicely with the Sustainable Development Goals, talking about sustainability today as well. And yeah, we are focusing on increasing quality of life for people through our robots. So that is really the focus on when we go into a project. We want to help humans with the robots in their everyday life. These 2 robots I'm going to talk about today. The first one is the UVD robot, that's short for UV Disinfection robot, and the other one is the PTR robot, Patient-Transfer-Rehabilitation robot. And the UVD robot, we started developing it in 2014. There was no concept at all, just knowledge that we wanted to reduce hospital-acquired infections. That was our goal. So you can see the normal process on the top without the robot. You do the manual cleaning, and not all surfaces are sufficiently disinfected. And with the UVD robot, does it work, the pointer? Yeah, with the UVD robot here, you have the manual cleaning, and on top you have the robot afterwards that comes in, that goes around the room and disinfects the room. And you might not know it, UVC light, it's killing bacteria, and that's why we use it for that robot. It is an environmentally friendly method compared to chemicals, for example. UVC light is not naturally found on Earth. It's blocked by the ozone layer, and it can only be found artificially. And that's why bacteria are not used to it and get killed if they are exposed to it. Now, UVC light has in the US been on the market for quite some time. There are manual solutions that you can see on the left. You need to put them in the room on one spot. Then you start them. You, of course, leave the room because it's also harmful for humans. And then they start disinfecting from that one spot. You then need to go in again, move the manual solution to another spot, start it again, and go out. So it can take up to 50 minutes actually to disinfect a room with a manual solution, and that's why we thought it would be quite clever to put that UVC tower on an autonomous robot. And that is what you can see on the right. So you can see that you put the robot in the room. Actually, you just open the door for it and it goes in. And then you start it. You close the door, start it on the tablet outside the room. So it's also quite safe. And the robot starts up, disinfecting inside the room and moves autonomously from spot to spot. And like that, reducing shadows, reducing shadows and actually covering a larger area in the room. And just so you get an impression, it is a bit of a commercial video, but I think you get a good impression of how the robot is moving and what the size of the robot is compared to the room and what you can do with it. So this is filmed with test tubes, so no people were harmed in the process. And as I said, 50 minutes for a manual solution. You could see 10 minutes for the robot, and in that 10 minutes, it has gotten through the room and disinfected the room properly. The second robot I'm going to talk about today is the PTR robot, and it's designed to help patients with temporary or permanent reduced mobility skills. You can see it can move a patient from the bed to a wheelchair. It can help people who have fallen on the floor, but it can also help with rehabilitation exercises. And actually, when we started developing both of these robots, there were manual solutions, but there were no autonomous competitors in the market. So mostly we tried to compare the manual lifting and manual disinfection versus the robot that we have. And when you look at manual lifting, it's quite exhausting for the healthcare professionals. You can also see there is 2 people lifting one patient, or even 4 for heavier patients, and they need to communicate, and that's quite exhausting for patients. And if you look at the, especially the manual solutions here in the bottom and top right, they don't feel very secure when you're being lifted in those lifting devices. Maybe you can already see it. It doesn't feel like you're really lifted properly and secured in it. And that's something we wanted to change. So on the right, you can see with the patient lifting rehabilitation robot, there's actually only one person. So it's possible to lift a patient with just one person, even though according to regulations, I think in most EU countries, I don't know about the rest of the world, you need to be minimum 2 people to lift a patient, just to have the patient securely lifted. But with the robot, I've tried it. It's not a problem to lift one person. And also, there are a lot of new ways that you can come up with to lift a patient, actually. So you can be quite creative on how you place it. For example, having the 2 beds here next to each other and just moving one patient from one bed to the other. That's not possible with the other lifting devices. So it's much more comfortable. It is much less exhausting for the healthcare professional, but it also gives the patient much more dignity while they are being transferred. And that was something that we were aiming at. So I've mentioned it in the panel this week already. There are, of course, a few autonomous solutions. Here you see a robot from Japan that is also designed to lift. It has a more animal humanoid form, and that is something that we actually wanted to avoid in our design, because we wanted to, in a subtle way, support the interaction between the healthcare professional and the patient. And here you can see that the robot is for the Japanese robot, the robot is more in the center, and the healthcare professional is more in the back, watching or maybe adjusting, but it's here it's the interaction between the patient and the robot that is in focus. And of course, that really depends on what you want to develop, and that depends on the situation and the application. But for us, it was important that the robot is more a tool that is supporting the actual interaction with the patient and the healthcare professional to make their lives easier. And also a little video here, just so you can see, because should I mute it? Okay. Can you hear it? And I think the video really highlighted that it can solve a lot of issues that we identified during our user research, and especially that you have a lot of equipment for just one purpose that the robot can combine in one solution. And it might look quite complicated and quite big, but if you once operated it, it's quite intuitive. Now, before we started developing the robots, we wanted to make a framework, come up with a framework on how we can support long-term sustainable implementation of the robots in everyday situations. And for that, of course, that it's important for us, because we want to make sure our robots are being used. They are scaled up in the end. They are getting into the hospitals, and of course we can sell a few more of them if users are happy. So of course that's an important point. But the important point is also that we really develop something that makes sense for the end user. And yeah, I'm just going to tell a little bit more about how we did that. This is not based on any literature. It's based on our experiences, that the team that worked back then together put together, and I think we had background from engineering, designers, roboticists, me looking at the human-robot interaction, and project development. So all that got into this framework. And today I'm going to talk about point 3, the Robi design and the Robi develop of these 2 robots. So the Robi design, that's a robot business design, we call it, is for us a partnership program where we co-create a robot concept and a business plan. And it aims to look at what is the task at hand, what is the challenge, do we actually need a robotic solution in this scenario, does that make sense, and would this be a good business for us to go into? And then eventually put that into a robot concept and also a business plan together with all stakeholders. So we have certain stages that we go through, and at each stage we check whether it still makes sense to continue. And the first one is, of course, the agreement and the project plan. And these projects, they started as public-private partnership projects, which I think is quite a good basis for a successful robot design, because you can take a little bit more time to focus on the user needs. You have a financial setup, and you have the commitment of the end users, because especially working in hospitals, that can be quite a challenge, because everyone is so busy that even though they are excited about developing a robot and they know it's going to help them, they have other things to do. And for the UVD robot, like I said, the goal was with the hospital in Odense to reduce hospital-acquired infections. And for the BTR robot, to support their healthcare professionals. And then also, because they were building a new hospital, it has actually just opened, and they wanted to increase the robotic solutions there and also look at how they should implement robots in the hospital, but also reduce, like I said, all the equipment that they had into one solution. So the robot was supposed to, or is supposed to, handle 90% of the patient transfers and rehabilitations for 785 beds. And the rest 10%, these are pre-installed ceiling lifts, because they are really intuitive, but they are not very flexible, because they are installed in the room and the patients can only be moved inside the room with those ceiling lifts. So what we did was we went quite a few times out, did field research, did workshops with the end users. Here on top, you could see I followed the cleaning professional quite some days, looked at her routine, looked at what she's doing before, what she's doing after, how much time she's spending in each room. We checked how big the hallways are, how many things are standing in the hallway, is it easy for the robot to go through, how big can the robot maximum be. And specifically with the PTR robot, we tested a lot of the solutions that they had there. So that was really a full day with healthcare professionals, with the hospital management, with patient representatives, and going around and testing all these solutions. Something that was very helpful for us is the job to be done, because there has been a lot of discussions throughout. You could see, I think, in the start, a project like this takes 4 to 6 months just to come up with a proper concept. And when you have so many people from different disciplines, there are a lot of discussions involved. So we really tried to be precise in the way we were working and agreeing on a lot of steps on the way. So the job to be done is very helpful to target the project scope and the focus, and usually formulated with verb-object context. And for the UVD robot, that was disinfecting bacteria on surfaces in patient rooms and adjacent bathrooms. And the PTR robot more had 2 of them support the patient during transfer happening inside and outside of bed, and lift, transfer, and lower patients who are not able to stand to destination. Yeah, and after all the field research, or actually while we did that, we had the data collection and the analysis. Show an example of that in a bit. We also did a lot of desktop research afterwards, writing the current scenarios, so really in detail, what are the cleaning personnel and healthcare professionals doing these days? How does their day look like? How does a specific patient lift look like in different scenarios? So it was quite a long document to be able to analyze everything and bring everyone on the same page, and also persona of everyone who is involved. And the desktop research was mostly also reviewing the guidelines and regulations, because both for cleaning and patient lifting, there are quite some regulations and guidelines involved. Like I said, minimum 2 people for lifting a patient in a hospital, which is a little bit also a challenge, because our business case was also based on that you save a lot of time, because you can actually do the lifting with just one person. And here you can see in the picture, you can see an example of that. Was just, of course, we had a lot of text, but we also tried to make it very simple for those involved who didn't have time to read everything, on how could a workflow look like with the robot involved, and to see whether that would fit with potentially the cleaning personnel, which we thought would probably operate the robot, but we didn't know at that point. Yeah, the data collection, you can see an example here. I don't think you can see the details, but whenever we did user research, field studies, also desktop research, we added the relevant fragments that you can see on the left to this document. It was a huge Excel sheet. Of course, noted where the source coming from. Here you just see examples from questionnaires. Then what the user need is, and we divided that here. This is from the PTR robot into categories. So, of course, working with patients, it should work in silence. So the category there is noise. Then there's a lot of user needs on space saving, and we tracked all of those and converted them into small guidelines, and afterwards also prioritized them. Yeah, and a little bit about the business side. I tried not to put too many slides about the business aspect, so I'll also hop over the business development stage here. But having the business case set was very important for us in the beginning, because it meant that the robot makes sense for the customer, and we'll be able to actually sell it eventually, because no one has any benefits if a robot is developed, but it's not a good business case in the end and doesn't get out on the market. So that's something we focused on, and actually all the user research we did in the beginning helped us to come up with these parameters here. These are just a few examples, and also to collect data on those parameters, so we could come up with a business case. And at the end of this, we had the concept, and then we had the business case, and we could say, okay, this concept, it makes sense. It makes sense for both of us. We'll be able to make a business out of this. Also existing solutions. I mentioned there were not a lot of autonomous solutions, but it was also important to analyze all the existing solutions. And here you can see example again from the PTR robot. We divided it up into the categories of the transfer, and then evaluated how useful are these tools during the lifting, and where do we want to be better in that. And of course the healthcare professionals helped us here to evaluate it. And once that is all done and we collected all the material and everyone was updated on the material as well, we had quite some brainstorming sessions that also ended up in a lot of discussions in the end. But we used, for example, mock-ups. You can see here that was for the disinfection robot. The red aspects are hotspots that the robot was supposed to disinfect. Here you can see some inspirational images when we had some brainstorm on how the robot should look like. And actually, these were some of the first concepts that came up, and you can see they look quite differently from the robots that we have right now. So for the UVD robot, initially, the idea was also to have, so it has arms, so it can actually target hotspots. We found out that it's not necessary because UVC light is so intense that you don't need to actually target. It catches the hotspots anyways. And here, actually on the right, you can see the small robot on the wall. That was the first idea of the PTR robot because space was for us an issue. So we said, okay, you can make a robot that is big and that can transport a patient, but then you can make it small and you can put it on a docking station in the room. But we soon figured out that that's technically impossible. So once we have good concepts and we collect the best concepts and again, decision-making, trying to facilitate the discussion, but in the end actually making a decision that we can prove has been validated by most of the people. And that's why we actually came up with parameters and then just voted. All stakeholders voted on what they think is the best solution that we should go ahead with. And once the concept and the business plan has been set, we go into the Robi develop. Now, I won't go into detail because that can take up to 3-4 years. But it is, again, we're a collaboration between the technical team and the business development team and a lot of testing being done. So you can see testing on the left in the technical wheel. It is very important for us that we have a lot of interaction with the users where they give us feedback, where we have user testing, and that takes a while. So that is quite an effort, but I think it's worth it in the end. So just an example of the evolution here from the prototype, and this was the first. It was a little bit more squarey than we had expected. When we had the design, I think you can see it maybe not on the next. I have a slide where you can see that it was supposed to be very smooth, but we couldn't get all the hardware in it and have it smooth at the same time. I think now it looks much nicer, but the first prototype still worked very well. And yeah, one more video. Let's see. And this video doesn't have any sound. You can see that's the that's one of the final prototypes at the end of Robi Develop. And why I put this video here is it really nicely shows how we got together. So she's a healthcare professional, and there was user and patient representatives, and the hospital management was there, and our developers and our developer, you can see the mechanical engineer also somewhere. They were all there, tested it, talked to. Of course, very difficult because we are a very international team and the healthcare professionals prefer to speak in Danish. So there are also communication problems. But for example, he's from Denmark, so translation, he could translate. But I think that's a very nice example of such final stages testing also that we had together with the end users that are so important because you always learn a lot from these sessions. Yep, plays again. Yeah, so this is the slide, the first one on the left. That's what we imagined it could look like, but the first prototype didn't look like that, obviously. But I think we're getting close now. This is how it looks like now. So it took a while. Actually, the 3.5 years, that's just from concept to the prototype in the middle. And to get to this stage took even longer. And when you see that this was the first prototype we had in the basement of our small company back then, it took a long time and a lot of technical discussions in the development phase also to come up with the prototype that works and is safe to use also for the user. Yeah, and after that, it gets interesting for me again. So we hopped over the whole development. That was a lot of technical challenges. I wasn't very much involved in that. Once we have the first prototype, we introduce it to the hospital. We leave it there. So we had a workshop with the caregivers to collect their input, to collect feedback, to see how will it work in the real world. We also noticed some technical issues that we could fix right away, and we also noticed some that we could get back to develop on. And this workshop was also to start up and to teach all the healthcare professionals who were supposed to use the robot, to introduce them to the robot and teach them how to use the robot. So you can see there was 98 participants. It took a few days, but it was really good sessions to get them introduced to it. And we also made use of that chance to collect data on the usability. And here we used the system usability scale because it's just a very straightforward questionnaire, and we can use it for all our robots and compare. And we got, of course, a lot of good feedback, and we were hoping for that because we spent so much effort including the user and designing something that is user-friendly for them. But still, of course, also we got some comments that, oh, I'm a little bit afraid. I don't think I would be able to do this without a technical person. And there are always, of course, people need time to get to know the robot. If I'm using a Mac, if I would now change to a computer that has Windows, it would take me quite a while to get adjusted to that. And even though I know it might be worth it, I get benefits. The healthcare professionals, they knew that the robot will help them, that it will be easier for them to transport patients, but they don't have the time to look into it, to get familiar with it, because I think right now we are already at a stage in healthcare where we are lacking so much personnel that it will be very challenging. That it is very challenging to introduce robots, because introducing robots to a hospital takes time, and hospitals, personnel in hospitals right now, they don't have time anymore, and that's a little bit of an issue and something that that is also a challenge for us. So we had, so this was just also a quote from one of the healthcare professionals, that we only use equipment that we feel very comfortable with. You never know how the situation with the patient might develop or even escalate, and I have no time to practice with the robot because I need to attend to my patients. So that is the challenge, that even though we developed a really user-friendly robot, that was a challenge once it got to the hospital. Yeah, and this is just a video to show, also doesn't have sound, to show that the robot fits through a door. It's but in a different way that you might think. You would probably usually transport a patient straight forward to the door, and now you're shifting. And there are a lot of situations where you would also not lift a patient like this on top of a bed. You would come from the right. So there are a lot of situations where the healthcare professionals need to rethink. They need to rethink the way they are transferring patients. And they can be really creative with this robot because it gives a lot of more opportunities. But they need to have the time and the creativity in their work to be able to do that. And that was very difficult for them because they didn't really have the time. Yeah. So how we tried to support it was we had our specialist. This is Britta. She is physiotherapist by background also and was our expert for the robot. I think she was there weekly after we introduced the robots, and she was always in contact with the healthcare professionals, checking in, are you using the robot? Why are you not using the robot? Should we maybe go through it again? Should I show you again? She also came up with new scenarios and a lot of videos on helping the healthcare professionals. So this is something that you couldn't do with a manual solution, lifting a patient in the bathroom who has been falling in the bathroom. So she came up with all these scenarios and videos and instructions to help the healthcare professionals in their work. And then she also educated super users, we call them. So yeah, people who are very open-minded, they are really interested, they have the energy, even though they might not have the time, they have the energy to learn something new, and they can be there for their colleagues, they can educate their colleagues, they can answer questions, they can be called if their colleagues have issues. And that worked out quite nicely and helped. This is something different, switching now to having the robot working in the environment. During COVID, there were a lot of new applications that came up for the UVD robot. It was specifically designed, and you could see that we had the scope, we had the stakeholders, and it was really designed to work in a hospital, to disinfect patient rooms. And during COVID, of course, everyone wanted to disinfect their places. So the robot got out to supermarkets, to airports, to prison, to schools. This is a hotel also. But the environment is different, the people are different, the end users are different, their workflows are different. So you really need to put a lot of effort into taking a robot from one application and transferring it to the other. You really need to be careful about that, and probably go through the whole first process that I introduced earlier, and analyze that again. I think now I have talked a little bit about the social and economic dimension of sustainability. What we didn't include really back then and weren't aware of is the environmental domain. That was something that more came up afterwards, and probably also we wouldn't have had the resources to actually think about which materials should we use when we develop the robot, or because it was difficult enough technically difficult to build the robot, to find the parts, to make it fit in a small version so that it can fit in a hospital room. But now slowly we are looking into how we can transition into more sustainable manufacturing of our robots. Of course, there we looked at the low-hanging fruits, transitioning to green energy, waste sorting was not really a thing in our company. Now it is. Refurbishment of robots, that is actually something that has been really good for us, because we can take back the robots and sell them as refurbished, and that has been appreciated also by customers. I know in some other robotic applications, it's not. But a robot that is working, that is disinfecting the room properly, is still good to go. Of course, we are also looking at regional centers, so we don't need to ship that much. And we have started to do life cycle analysis for our robots, specifically for the telepresence robot that I didn't talk about that much. So trying to put effort here and there as much as possible. And why we're doing this is, of course, because we're all nice people and we want to have the best for our planet, but also because our customers require it more and more. So we have also big customers who want to have the robot in their office space or in hospitals, in big hospitals, and they require to know where the parts come from, how the robot has been made. It can also be a financial benefit, like the recycling robots that we could resell them. It was also for us something to attract investors in the end, to have a more sustainability agenda. And how we did it was partly internal budgets, but we also used student projects, for example, for the life cycle analysis. And in Denmark, there is a lot of national funding that you can use, not for robotics, but just helping SMEs to become more green. Yep. Next steps, that was for us modularizing our robots to optimize the transportation, because they are very big. And also the flight cases, they are very big. They take a lot of material. And actually, we had the ISO 14001 certification on the list. I think 2 weeks ago we got it. So that's a really good achievement also for us, and also an achievement internally, because it's not only now, it's also in the future. We need to keep looking at it. So it's a constant reminder that we need to keep environmental aspects in mind. Yeah, those were just a few ideas, and of course, all the things I presented today, especially the Robi design and develop, that was not only me, that was a whole team of people. I hope I have mentioned most of them here. Yeah, I'm looking forward to your questions. And of course, here you can see me playing around with the PTR robot, trying to look at, so what can we do with it in the future? Right now it's operated by humans, but what if we put AI in there? Can we enhance rehabilitation? How can we make rehabilitation more interesting? So that's another whole topic that is very interesting to look at, because there's a lot of potential, especially in the PTR robot, on what you can do with it in the future. Yeah.
Okay, thank you very much. Very nice talk.
Sure.
Any questions?
Hi. Very nice talk. I think you get this question a lot, but what's the impact of the introduction of the robot for healthcare professionals? Because you gave that quote, that was very nice, but you also mentioned that it takes fewer people to lift someone.
Yeah.
So what are the others doing? Right? So what will that's the question.
Yeah.
Wouldn't it be better, because to explain to a healthcare professional how to operate a robot is not necessarily straightforward, wouldn't it be better to have a specialized operator in every hospital that is only dedicated to this robot, so you don't have this conflict with healthcare professionals, making them feel they should learn how to operate a robot? What do you think?
Yes. So the first question, not sure whether that hint at the robot is taking the job of the other three, sure. But well, you might, and I mentioned that you might know that we're lacking healthcare professionals, we're lacking personnel in the hospitals. So I'm pretty sure there's something to do for the other three, and they're super happy that they don't need to do it. And actually right now, even though there's the guideline that minimum two people should be lifting a patient, that's not always the case, because you might not be able to find someone that quickly to actually help you lifting a patient. So it is for them more a support, so they can focus on other more qualitative tasks, hopefully, and actually give the patients the care that they need at that moment. Because I've heard stories about patients lying on the floor for a long time just because the equipment wasn't there or the personnel wasn't there. So that's more the situation than actually the people worrying about their jobs in this specific area. Yeah. And what was the second question? Oh, yeah, having the operator. I think it would be a lot to organize if you have one. So you imagine that you have one person that can be called in order to lift a patient. Yeah. I think it's the same situation. I think it would take too much time, and it is really not a difficult device to learn. So you can easily take it like any other device and work with it. But maybe having someone there who can come and help or support, and that was the idea of the super user, is time-wise a better solution. Because I know you're nodding. In a hospital, everyone kind of needs to do all the tasks, so it doesn't make sense to have just one person doing something. Yeah.
Thank you for your presentation. As somebody who I educate people who are going to be physical therapists in the United States or physiotherapists in Europe, from our knowledge, our experience, that the thing that takes the most people and is the most dangerous is proper placement of the patient in the sling device.
Yes. Yeah.
And so I'm curious, do you have any strategies to facilitate that in this population you're trying to serve?
That is a really good question. So what we did with the super users, and Britta, who I mentioned in the hospital, she was really educating people on this matter, also on how to do it and how to improve the lifting. So it was not only about the robot, it was also about the education in general. But about the sling, we can't do that much about it. We've had, I think, even 2 projects. So in the beginning, when we looked at the robot and developed the robot, we wanted to have a new project just to design a more robot sling that can support the patient better. But it's too complicated. And the hospitals, they have their equipment, and they have the equipment that they have bought, and they rebuy that. And it was obvious for us that it's going to take a long time, and it's going to be very difficult to get into that, to design a new sling and to have that marketed together with the robot or on its own. So I think it's definitely a need, but it would take a long time. So that's why we didn't get into it.
Great, thank you. A follow-up question.
Yeah.
My experience of seeing new equipment being applied in a hospital, oftentimes the value of that equipment is not based on what it does and if it does it well and does it not take up space, but how it impacts other things that professionals are required to do. And I'm curious, is that part of your evaluatory process, and do you have a sense of those type of outcomes?
How it...
So like,
give an example?
Yeah. So say for example,
Yeah.
Nursing may say, well, okay, this is great. It can pick people up. That's great.
Yeah.
But you know what? This is a barrier to me to go in and take the patient's blood pressure, so I'm not going to do this.
All right. Yeah.
So, so I'm curious if that's something you can evaluate, or maybe it's a non-issue. Maybe it's just my perception of, okay, I've seen lots of new equipment introduced, and it ultimately not be accepted by the healthcare practitioners, not because of what it does, but how because it impacts other things that are going on.
Yeah. We haven't really had that issue. It was more to I think through the interaction it was mostly solved. So I'm not sure how it is now. So we also want to go back now and follow up on it. But in the beginning, especially when we were there each week, it was easier to follow up and comment on these issues. I think the communication, that was the most important aspect, to communicate with everyone who's using the device, and that's what we did weekly. So I don't think if it came up, then I think they more or less solved it. I think that the issue was more the timing, and another issue that we of course had, the robot was designed to fit in the new hospital, but the new hospital wasn't ready yet. So the rooms were smaller, the ceiling was lower, you needed to be careful that the robot, if it expands, that it, the robot takes care of that, but then it stops if it's about to hit the ceiling. So these were issues that we had when we first tried the robot, because we weren't in the new hospital yet. Yeah, but...
Great, thank you.
Thanks. You have a question from Austria, from Profactor. Sharat asks if you were there any situations where you had the patients in using the robot, and what did you do to convince them?
Oh, so where they didn't want to use the robot?
I think so, yes.
Yes. Good question. Yeah, there were quite a few healthcare professionals that were skeptical. I think these workshops helped a lot. So what we did was that, of course, we don't force them. So they can become comfortable, and they don't need to use the robot in the beginning. So they knew that eventually the hospital is going to shift to the robots. But there's a long period where you have the manual devices, you have the ceiling lifts and the robot. And I think that gave them a little bit more trust that, I'm going to learn it when there's time for it. So through the workshops, some of them, they just joined the workshops. They just looked at how their colleagues were interacting with the robot, were bringing up new scenarios. And I think when you're in that group, then it's easier to get involved. And then maybe your colleague says, come on, just use the joystick for once, and you use it, and it's actually not that difficult. So that this was a way to slowly get them to have these group works for the first workshop, but also the continuous workshops to get them more and more involved. And sometimes, of course, it's also when they are alone with their colleagues, so we are not there, and they are maybe not that much afraid of breaking the robot because it's only them, and that makes them feel more comfortable. So then the super users who could also educate other colleagues were also very helpful in that respect. Yeah.
A question from my side. In relation to the sustainability and also accessibility and so on. So you showed the robot for hospitals, but how affordable or how accessible is it for home usage? Because there are so many patients that is taken care of at home, and their caretakers are more open and enthusiastic to be your super users, at home. So how close are your product is to be used at home?
Not that close, because already the old hospital was pretty challenging environment for us, and that's still quite a big environment. And the home, you have stairs, you have cluttered environment, you have not enough space. So it's of course on our list, but we know it's challenging. You would need to design a complete new, smaller version for it. So it's definitely right now not on the major to-do list. But retirement homes are. So that's an area where you could use the robot, where the scenarios are also very similar. So a transfer from the hospital area to the retirement home area would be easier, not that much work.
Thanks. I have one question for the co-creation you mentioned.
Yeah.
I think you showed some brainstorming and also some evaluation tables where you mentioned there has been stakeholders involved, but I was wondering how far does the co-creation go? How much influence can the users really have on the design process?
So I haven't measured that, but you could see the sheet, and we also put the importance of the input there. So of course every aspect that the end users mentioned, and of course the focus was more on the healthcare professionals than on the patients. They were also involved, but this was something we also wanted to develop for the healthcare professionals. So I think definitely all the things that they wanted were considered, but at some point you need to prioritize. But also that prioritization happens with the end users, so that you don't come up with something that they are totally against. But of course there are a lot of wishes when you start and you tell them, oh, we would like to develop a robot that can do this. Can it also do that? And could we get this? So of course there are a lot of wishes that all landed in that sheet, but eventually through prioritization we ended up with the main important ones. So definitely they had their say. Yeah.
Thanks. Do we have time for one more question? Okay, one last question then from my side. You said also that you used LCA for the robots or introducing it.
One robot, yeah.
I think, as far as I know, it's not been done a lot, and when so, there was a lot of trouble with the databases, non-existing databases. How would you maybe in a very short, brief sentence say how your LCA experiences are at the company?
Oh, yes. Yeah, so that was our telepresence robot, because because the telepresence robot, we just wanted to see how what the footprint is, also because we advertise it that you can save flights, because you have the robot, you can log in to be in another place and you don't need to travel. So there it was very important that we check, okay, how much, what is the footprint actually from producing it. And it was a student project, so it was not that detailed, but it gave a good direction and a good basis. But it is challenging with the software programs right now, and the data there is on the sensors. Now, I think with that robot, it's one of our latest robots. It was a bit easier because we have very new sensors and cameras and everything. But I can imagine that, especially for the PTR robot, where we have a lot of small components, that it will probably be impossible to find them all. So it's a challenge.
Thanks.
Yeah.
So, is there